Thank you so much for watching our introduction video of CJ Bio Enzyme. So through this video, I hope you have learned the necessity of enzyme and CJ Bio's enzyme related business as well. So ladies and gentlemen, now let's deep dive into our Q&A session that you have all been waiting for. So we are joined by three speakers who delivered presentations today. So Dr. John Plesky and Dr. Jecher Kim will be joining us online, and Dr. Eunjung Choi, he is here at the studio to have questions from the floor. Thank you. So before we begin our Q&A session, once again, thank you very much for your attention. And we do have a lot of questions from the floor. So there will be two segments of this session. First of all, we would like to have questions that we have received in advance. And after that, we'll move on to questions that we have during the presentations, during the webinar. So ladies and gentlemen, if you have any additional questions, please write them down on our chat box. Thank you. So the first question goes to Dr. Plesky. But when we have answer from our speaker, Dr. Kim and Dr. Choi, if you have any additional comments, please chime in if you can or if you want to. So now let's move on to the first question. So I will read for you. Out of fermentability, water holding capacity, and bulk density, what property is more relevant to functionality of dietary fiber? So this question goes to Dr. John Plesky, please.
Thank you for the question. Yes, it depends on the, I guess the answer depends on the function. As we've explained during the seminars, there are many different functions that fibre can do in pigs and poultry. If I give an example in sows, for example, that are about to farrow, then water holding capacity is important to prevent constipation. But if we're talking about the physiological functions of piglets and growing finishing pigs, for example, then the fermentability of the fibre sources to produce short-chain fatty acids and to have the beneficial effects, as we have explained, is going to be more important. Therefore, it does depend on the age of the pig or the bird, and it depends on the particular function. For example, gut health, that might be of interest.
Thank you so much for your meaningful answer. And let's move on to the second question. And this time we would like to have some comments from Dr. Kim. So applying energy metrics with argilinase supplementation should be conservative as there will be variation in energy contents in raw materials. On what basis do you recommend full energy metrics application? So that will be the question. The floor is yours.
Thank you. Thank you for the question. It is a quite relevant question given the high ingredient cost at the moment. I understand that there is always variation in nutrient content and also energy content in individual feed ingredient. And at the time of mixing the diet, these variation will be affecting the energy value of the feed, and therefore the amount of energy that we can actually release from the feed by use of exogenous enzymes. But I think it is a very good time to review that again and then be more aggressive to apply full metrics of energy, because that is basically our money for the feed mill operation and animal production. So even if you maybe fail to optimum growth for about 5-10% of the 5-10% of time by applying full metrics, I think reducing the feed cost by applying full metrics is more beneficial for whole industry. Particularly at this time with the high feed cost situation. So yeah, on the basis of that, I guess it's a good time to apply full metrics.
Thank you so much. And now we'd like to move on to Dr. Choi. So are gynolinase inhibitors present in animal feed? Aren't they destroyed during a pelleting process?
Yes, so the xylanase inhibitors are in feed depending on the sources, and it's known to exist in high levels if you use wheat or rye as your source, or it's known to be in lower levels in corn and barley. The second question is if it gets destroyed with heat. And as I explained in my slides, xylanase inhibitors are proteins. So of course they will be denatured if you place them under high temperatures. But there has been tests done on different conditioning, pellet conditioning temperatures, and extreme heat does lower their level, but maybe 70, 80 degree, they're still there.
Thank you so much. And the next question goes to Dr. John Plesky. So would there be recommended soluble NSP or insoluble NSP contents for piglets and sows?
This is a very good question because unlike energy or standardized ileal digestible amino acids or calcium or phosphorus, there are no, I guess, official recommendations for soluble and insoluble fibre for pigs of any stage, let alone piglets and sows. Typically, however, and this is more anecdotally, the sows can obviously tolerate higher levels of total dietary fibre than piglets can. If we look at piglets first, then it depends on the phase after weaning. Phase 1 diets, you're probably wanting a minimum of 12 to 14% total dietary fibre, with a substantial proportion of that being in the form of insoluble or moderately fermentable fibre and less soluble fibre. As the piglet matures, its digestive tract matures, then up to about 16 or 17% total dietary fibre. For sows, they can tolerate more fibre and generate energy from the fermentation. The evidence would suggest that sows can tolerate relatively high levels of total dietary fibre, up to 30%, even more, as Dr. Kim alluded to, without impacts on sow and piglet performance. But digestibility will decline, and that may have consequences for environmental effluent. But in any of those classes, then enzymes should be considered the appropriate enzyme should be considered to generate the extra energy and reduce diet costs.
Thank you so much. Is there any comment or further ideas on this question? No, okay, thank you. But if you have so, please chime in whenever you want to. And this question this time goes to Dr. Kim. So you mentioned that VFA contributes between 60% to 27% of maintenance energy requirement in grower or finisher pigs. So what about broilers then?
Good question, and I had the same question in my mind, but there's not I haven't seen any study that actually measured VFA production in the cecum and large intestine consistently, and in relation to how much energy is actually released from the volatile fatty acid in broilers, and then considering that the length of the digestive tract is much shorter in broilers, and then the time digester actually staying in the cecum and large intestine is much shorter than pig. My best guess is around 5 to 10% of the maintenance energy may be contributed by volatile fatty acid person, mainly the cecum in broilers.
Thank you so much. And now this question goes for Dr. Choi here at the site. So can we analyze xylanase inhibitor in feed?
Yes, there are indirect methods where you can extract xylanase inhibitors from feed into buffers and indirectly measure the xylanase functionality in the extract. But the xylanase inhibitor assay that you saw in my talk was actually done with recombinant inhibitors expressed in E. coli or Pichia.
Thank you so much. And now let's go back to Dr. Plesky. So you mentioned that GIT hormones such as GLP-1 and PYY reduces digestive flow. Reduced digestive flow or increased retention time is beneficial in terms of nutrient digestion. So that's the question. The floor is yours.
Thank you. I think this really relates to whether we're talking about the more soluble aspects of fibre or the less soluble, the more insoluble forms. Certainly, we know that that with soluble fibre that causes viscosity, or the addition of soluble fibre at levels that can cause an increase in viscosity, then this will decrease energy and nutrient availability to the pig, and particularly to the young bird. In that case, soluble fibre will decrease transit time, and that is not necessarily beneficial in terms of energy and nutrient availability. But of course, we have enzymes that can alleviate or mitigate those effects. Certainly, insoluble fibre, if we're talking with respect to, for example, intestinal structure and function, then having a higher degree of less fermentable fibre will increase the transit time, reduce the retention time, and that can have gut health benefits, particularly for young piglets and for young birds.
Thank you so much.
Can I add a bit more?
Oh yes, yes, sir. Please.
Yes. In broader cases, what Professor Plasky actually answered is most cases of the pig, but in broader cases, there was a study looking at the release of peptide YY production, particularly in the large intestine, when there was increasing fermentation of fiber. And this PYY actually sending negative signals to the animal and decreasing feed release from gizzard into the small intestine. In those cases, in broader case, they actually increasing the time frame that digest are staying in the gizzard. Therefore, they are grinding materials a bit finer, and that basically contributed to increased nutrient digestion in broilers. So, for different animal, as Professor Plasky said, different animal, different classes, and how much microbiota developed in the gut, that all contributes to effect of the fiber in the animal. So use of fiber in monogastric animal has to be targeted for different classes of animal, and what purposes you are actually targeting to achieve in diet formulation is going to be a important factor.
Thank you.
And can I just add to that too, please?
Of course, yes.
One thing I forgot to add was that, and Dr. Kim is correct with the feedback mechanism. So peptide YY and glucagon-like peptide 1 will actually send a form of negative feedback in the pig, at least, back to the stomach to reduce the exit of digester from the stomach into the duodenum. And that will actually increase retention time in the stomach, and that will allow for a greater protein digestion. So it's an orchestrated mechanism. And I fully agree with Dr. Kim. It is not necessarily straightforward, and depends on certainly the physiological stage of the animal and the type of animal that we are talking about.
Thank you so much. Any additional comments? If we don't have further comments, we'd like to move on to the next question. So this time we'd like to ask to Dr. Kim. So the question is, are the chain length of the xyla oligosaccharides are important? If so, why?
Thank you for the question. I think Professor Plasky already explained it. Long chain rabinoxylan, which is usually found in feed ingredient, is not well utilized by microbiota, and it actually exerts a lot of different negative impact on the physiology of digestive tract. And if you actually reduce that degree of polymerization of rabinoxylan, which is very long chain to a shorter chain, as as we actually showed with our CoJS Jalanage, you can actually providing a very good energy source for good, healthier microbial composition in the gut, and then this microbiota start utilizing it and growing it. So supplying, the wide amount of these short chain oligosaccharides, xylosaccharide particularly, is very important for good function of the gut, or healthier development of the gut microbiota, and it largely depend on the chain length as well.
Thank you so much. And let's move on to Dr. Choi here. How much glycanase inhibitor will affect the activity of the glycanase?
So that actually depends on the xylanase inhibitor, what type xylanase inhibitor and what type of xylanase it is. But if you just consider the usual amount of inhibition that xylanases get, it's about nanomolar scale inhibition. So that sort of gives you an idea about how tight the inhibition is.
Thank you so much. And let's go back to Dr. Plusky once again. So the question is, structure or particle size of fiber affects digestive physiology in pigs and poultry?
Yes, traditionally, a coarser particle size achieved through the grinding process of an ingredient is associated with poorer digestibility, and therefore poorer availability of energy and nutrients, and that is why there are recommendations for an average particle size for different ingredients for both pigs and poultry. That can change with the physiological stage of those animals, but typically a coarser particle size is associated with poorer availability. However, with the current environment that monogastric animal production faces, for example, with antimicrobial use and antimicrobial stewardship, then aspects such as particle size and the structure of different feedstuffs is becoming really, really important. And certainly there is evidence that, for example, with wheat bran, a fibre-rich ingredient, then feeding a coarser particle size, an average of about 1,100 microns, to piglets after weaning has a positive effect on reducing pathogenic E. coli excretion. And certainly in birds, the concept of feeding coarser particle size, in some cases whole grain, has been around for a considerable time. I think this is an area of significant interest. The challenge for production, the challenge for feed manufacturers, is how you can take advantage of a coarser particle size to reduce pathogenic load in the gastrointestinal tract, whilst trying to incorporate that into a pellet, and how that impacts on feed mill efficiency and pellet quality.
Thank you so much for your meaningful words. And let's move to Dr. Kim once again. So the question is, if XOX is so important, then why not supplementing XOS in the feed rather than adding glycanase? So that's the question.
Thank you for the question. Yes, as Professor Plasky already mentioned, xylo-oligosaccharide is produced industrially and is available in the feed market. I guess there's about 8-9 different companies supplying xylanase to the market. But it is very hydrophilic, so it is very difficult to maintain its form without forming lumps during the storage and production of feed. Secondly, also it's very expensive. And then considering that, if you remember one of my slides, that we actually have around 40 to 80 kilos of rabinoxylan in feed material for metric ton of feed, and then it's a huge amount of rabinoxylan available. Then why can't we just produce xylo-oligosaccharide in vivo, which will be probably which will be actually having the same effect of the adding xylulose into the feed. So I guess it's much more efficient, not efficient, much more economical compared to adding xylulose into the diet.
Thank you so much. And now let's go back to Dr. John Plusky. So the last question that we have received in advance will be this one. So if we have limited capability to alter dietary fiber content in a formulation, for example, high fiber diet due to ingredient constraint, then what would be the best strategies we can take to maximize the nutrient utilization efficiency?
Yeah, particularly a very good question, particularly in the context of the very, very high feed prices that that the world is experiencing at the moment, and lots of nutritionists are desperately trying to work out how to maximize feeding efficiencies. I think it's a back to basics approach, paying attention to the basics of feed formulation principles: energy, amino acids, minerals, vitamins, and how that all fits together in a diet. Trying to reduce the safety margin associated with within limits associated with energy and nutrient specifications that are in diets. I really do think enzymes are now, and I fully agree with Dr. Kim about the matrix values. Now is the time to exercise as much as possible within the constraints. The improvements in energy and or amino acid and or phosphorus availability from enzymes. But just a note about fibre, yes, the bulk density of some ingredients does limit its inclusion and does limit the way it can form a pellet, for example, but there are available very highly purified sources of fibre that can be added at much lower inclusion rates than traditional ingredients to achieve similar effects, and that is also worth consideration.
Thank you so much, Dr. John Plusky. And from now on, we would like to introduce some questions that we have on our chat room. So this time, we would like to ask Dr. Kim, first of all. So the question is, in terms of cost efficiency and maximizing the energy output, is it possible to reduce the usage of butyric acid additives and replace it with coreous glycinase?
That's a very good question, and I think when we actually presenting this action of coreous glycinase for production of or increasing production of short chain fatty acid in the gut, this question is quite often asked by many formulators because they're actually using particularly butyric acid or propionic acid in the diet to improve the gut health, basically. But you know that adding propionic acid and butyric acid in the diet will be very quickly released in the stomach, and then most of them are absorbed in the small intestine or being utilized before they reaching into the large intestine. But use of glycinase basically creating short chain xylosaccharide from in the small intestine that delivered to the large intestine, and volatile fatty acid, particularly butyric acid and propionic acid, produced in the large intestine, where we need to control the microbiota, basically. So I think the functionality of the volatile fatty acid as an additive and the volatile fatty acid produced by fermentation of fiber will be a little bit different. So addition of volatile fatty acid in the diet mainly controls microbiota in the small intestine, and with the enzyme produced volatile fatty acid mainly contributes in the large intestine.
Thank you so much.
Can I just add to that, please?
Of course, yes, please.
Yes, just very quickly. As I've shown in one of my slides in my presentation, the average retention time in the large intestine of the pig is anywhere between 24 and 48 hours. Therefore, there is a lot of time a lot of, and therefore a lot of substrate in the large intestine for the bacteria to metabolize. And certainly the addition of the endogenous production of butyrate to have beneficial effects is much more consistent and much more timely in terms of its release. One of the issues with adding an acid such as butyrate to a diet is that it's a pulsatile release because it depends on the consumption of the pig and when the pig eats. Whereas the digester in the large intestine, if it is there for a long period of time, then you have a consistently reliable production of acid, and more. I guess that permits more opportunity to have a benefit.
Thank you.
I think I actually didn't give a proper answer to the question, because the question was whether they can actually remove or partly remove the addition of butyric acid in the diet when we're using cogestionate. And then, as I said, the site of the action of added butyrate and then the produced butyrate in vivo is quite different. I guess if you're really worried about the small intestinal health, you may be better to, include that butyric acid in your diet, even if you're actually using cogestionate. That will mainly control microbiota in the large intestine.
Thank you so much for your comments as well. And at this time, we would like to ask a question to Dr. John Plusky. So how we improve the quality of carcass in finishing pig when using the high fiber diet? So Dr. John Plusky, do you have any suggestion?
Yes, I did refer to that or allude to that in one of my slides. That's slide number 23. That looked at the impact on distillers' dried grain solubles and dressing percentage, or the carcass percentage, if you like. And certainly one of the negative impacts of feeding DDGS is impact on the iodide value, the quality of the fat, and also a reduction in the dressing percentage. And that is a well-known impact of feeding high fibre diets, if you like, in finishing pigs. I guess there are a couple of strategies. And again, as I've shown in that slide, you can withdraw the amount, or withdraw the, in that case, DDGS from the finishing diet before estimated slaughter, and that will restore the carcass weight. Another strategy is, depending on the types of ingredient, is to use an enzyme. There's some work looking at high levels of wheat bran, where the appropriate enzyme combination resulted in pigs having similar carcass weight and similar carcass characteristics to control pigs that were fed a lower fibre diet. There are strategies associated. There certainly are strategies associated with mitigating high fibre diets for finishing pigs.
Thank you so much. And ladies and gentlemen, now we would like to introduce the next question. It goes to Dr. Eun-jung Choi this time. So the question is that, do you have a result on a microbiota improvement by employing enzyme? For there seems to be only in vitro experiment result covered in the slides. Furthermore, how the practical condition is in plant?
So actually, we don't have any microbiota test results or in vitro test results, and those are actually, we are in the process of producing them. I just wanted to show you some of the biochemical and the structural characteristics of Coregest. So once we get those data, we'll definitely be able to provide them for you.
Thank you so much for...
Add in there,
Oh,
please.
of course, yes.
Yes, if you remember one of the slides that Dr. Plusky showed, that was conducted piglet study in the North Carolina State University. We actually measured microbial composition in piglet with and without addition of a cogestionate, and we found that by adding cogestionate, there was a significant increase in fiber fermenting microbiota. So we have some in vivo data, which is not yet published, but it's in press at the moment.
I guess I wasn't aware of it. Thank you, Dr. Kim.
Okay.
Yeah,
Thank
and
you.
if I can just add to that in general, please. These are entirely expected results. That I don't think they're surprising in any particular way at all. Understanding enzyme substrate interactions and understanding the digestive physiology of the pig. I think one of the challenges is how to do this reliably and consistently. And there's certainly growing evidence that these beneficial effects, for example, on post-weaning gut health parameters, can be mediated by the use of appropriate enzymes, driven through changes to the microbiota and host responses in association with those.
Thank you very much. And this might be the last question, and the last question goes to Dr. Kim. So as there have been developed lots of feeding additives based on SCFA, I want to ask the different effects on pigs or chickens between adding SCFA directly and increasing SCFA, and indirectly by adding enzymes. So that's the question.
I think I partly answered that before when there was a question about the butyric acid, whether they need to add it in the feed or not. As I mentioned before, there was particularly in chicken, because the digestive staying in the gastrointestinal tract in the chicken is very short, like around 4 or 5 hours. The amount of the volatile fatty acid production will be significantly lower compared to pig and pig and other animals. So if you actually are targeting improving small intestinal health, addition of short chain fatty acid in the feed is quite effective. But with xanonate addition, producing xylosaccharide in the small intestine, and that delivered to cecum and large intestine, and then producing volatile fatty acid in the lower part of the gut is actually affecting microbiota mainly in the large intestine. So quite same product, but it's quite different function, and the site of the action of these different products is different between added short chain fatty acid and produced short chain fatty acid in the large intestine. So I guess it depends on what you're targeting in your formulation. Are you targeting for small intestinal health or targeting for shifting microbiota in the large intestine? Then co-digest will be better option. But if you want to improve small intestinal problems, then addition of short chain fatty acid in the diet will be working quite okay.
Thank you so much. If there is any additional
I was
comment?
just going to say,
oh yes,
please, I think they're complementary therapies. You can have both. It really depends on the target. That I agree with Dr. Kim.
Thank you so much for your additional comments as well. And thank you once again to all of our 3 speakers for giving us very insightful words. Due to limited time, ladies and gentlemen, this brings us to the end of the Q&A session that we have prepared for you today. Thank you once again for leaving such good questions. But if you want to have some more answer or comments from our speakers, please send us your comments or questions via email. So we have 2 email addresses. So the first one is jy.shin9@cj.net. And the second email will be dykim19@cj.net. So please do not hesitate to send us any comments or questions. We will work very hard to answer your questions through email. Thank you once again for your cooperation. So ladies and gentlemen, we've almost come to the end of our webinar today. But before saying goodbye with our speakers, we'd like to ask our 3 speakers to give closing remarks. So first of all, Dr. John Plasky, if you are ready, the floor is yours.
I would just like to thank CJ Bio for the opportunity to be involved in the webinar today. I think under the current economic circumstances of feeding monogastric animals, then conferences and webinars such as this are vital, really important information to sustain the viability of the monogastric intensive industries. So thank you again for having the opportunity to be involved.
Thank you so much, Dr. John Plasky. It was an honor to have you at our webinar today. Thank you once again for your participation. So next, thank you. And it was our second speaker, Dr. Chechur Kim. The floor is yours. Please give us one last word. Thank you.
First of all, thank you everyone for joining this webinar. I know that time is very valuable for you guys, and taking about 2 to 3 hours out from your daily schedule is a very brave decision. And then I hope actually we paid off your time by delivering important information during this webinar. And then if anything that you actually want to discuss more, I will be always available, and even I can visit you and see face to face. And then that's something I'm really looking for in the future. Thank you for joining again, and see you soon.
Thank you so much, Dr. Kim. So as he just mentioned, thank you once again for taking your time out of your busy schedules to join us today. And last but not least, here at the studio, we're joined by Dr. Eun-jung Choi. So please.
So it's a very exciting time at BP R&D, CJ's R&D Center for Research. We're in the process of developing many different feed enzymes. And I want everyone to keep an eye on, watch out for these new products. So thank you so much.
Thank you so much. So as she just mentioned, we would like to ask for your continuous support and interest. Thank you once again, ladies and gentlemen. So this brings us to the end of the 2022 CJ Bio ANH second webinar. Once again, we would like to extend our sincere gratitude to all of our speakers, participants. Thank you once again. Goodbye.
Grow and Act.